Hello, welcome. Welcome to this ViaLite live workshop and Q&A session for CommunicAsia. So good afternoon to you. It's good morning from the UK. It's just breakfast time here. My name is Richard Jacklin. I'm the Senior Vice President of ViaLite Communications. I'm here with Sean Walker.
Good morning.
And he is in charge of our customer service team for the ViaLite customers. So if you don't know ViaLite, we are experts in RF over fiber. You'll see us used in lots of applications in satellite communications, broadcast world, GPS timing and routing, and defense and mil aero. We cover frequencies up as high as 7.5 gigahertz today. So if you want to find out more information about the ViaLite product range, we've got resources here on the CommunicAsia stand. Just look on the virtual booth, look for the resources. You'll see us in the Satellite Asia Hall 2, or go through the Great Britain stand area. If you want to get information directly, then you're very welcome to visit thevialite.com. So what we're going to do in the next 20-25 minutes is talk things RF over fiber. We're going to show you some products, show you how they're designed, maybe some installation techniques, particularly with Sean here, but most importantly, answer questions that you have through this just informal session. So you're welcome to shout out or use the chat function on the Zoom. So let's get started. So we're talking RF over fiber. Why not use coax? Well, coax is obviously a great product. It's used in everywhere, still in communication systems. But as you get in longer lengths and higher frequencies, coax becomes more lossy. You lose more signal. It also suffers from immunity. So although it's a shielded product, you still have immunity issues. It's becoming more of a problem for security and cybersecurity. But if you compare it to fiber, which of course solves a lot of these things, fiber is much smaller and lightweight. I mean, Sean's got a couple of examples here. You can just see the type of product. That's a small patch cable. So quick introduction to ViaLite products. So we're going to show you a few things today. So this chassis here is a 19-inch standard chassis, 3U high. It has 13 module slots, which you can slot cards in. Now, in the ViaLite range, you can have options. You can have one module per slot. We can also actually have two modules per slot. So you can have what we call two transmitters, two receivers, or a transceiver type function. So what that means is in a chassis like this of 13 slots, we can have up to 26 RF channels. Also in a chassis-based system, we have what we call the SNMP card. So this offers your monitoring and control. It connects into the cards. You can do parameter changes. You can monitor what's happening with those cards. Also in the rack, we've got two power supplies. So if you're doing carrier grade type communications, obviously reliability is key. So we offer the product with two power supplies, so that is power balanced and offers redundancy if in the unusual case that one of the power supplies should fail. So that's our sort of basic system. I'm also going to talk about other form factors today. We've got products not just in the card chassis format, we also have them in module format. So we have the basic same modules, but contained within what we call OEM modules like this. This one's the blue OEM, it's blue. It's in a kind of an alloy extruded case. And then we also have versions, proper OEM versions, that go to customers that allow them to actually integrate it into their own product. So particularly useful for broadcast customers that want to use these kinds of products for things like integrating into wireless camera systems or wireless microphone systems. They can integrate this into their own products. So the ViaLite technology is under the skin, a bit like the Intel Inside type approach. So we're just going to start the demo by just sort of looking at a simple link and build it up from there. So in this chassis system here, we've got a transmitter card you've got a receiver card. So the transmitter card takes electrical RF energy and converts it into optics. So then we have a cable. This is just a short patch cable, but this can be meters, hundreds of meters, kilometers, tens, or even hundreds of kilometers long. We connect that fiber through to a receiver card. So receiver is the other way. So it's optics back into electrical. So in the demo I've got here, I've got a DVB signal, which is going into the transmit card, converting into optics, and then I've got my receiver card converting it back to RF, and you can see it here on this analyzer. You can see kind of like an 8 megahertz bandwidth just coming out the other side there. So if you're an experienced RF engineer, you'll know about the things you need to take care of when plumbing RF cables together, how you look after them. But common questions we get with this kind of kit is around the fiber cables, the types of fiber cables, and how to look after them. So, Sean, do you want to just give us a quick overview on that?
Yeah, so some of the fibers we use, one of our most common fibers is the SC APC connector, and you'll see all of our fiber connectors are green, which is our APC connection, as opposed to the blue, which is the PC connection. We also have FC APC, and these connectors have a keyway in them and allows them to lock, so it protects them even more. And we also have LC connectors, another type of connection, again green for the APC, and also there is the E2000 connector, which sometimes comes attached to our green and yellow modules.
Okay, so plumbing these things together, you're slotting them in. How do you kind of know that they're properly fitted?
So one of the tools we use on site, Richard, one of the most important tools is our optical power meter, and our optical power meter allows us just to measure the optics coming out of the fiber optic cables themselves.
Okay.
So if I take the output from the transmitter here,
yeah,
this is the transmitter.
Yeah.
So if I just take the fiber from the back of the receive card and pop it into the optical power meter, and you can see I'm getting a reading there. I don't know if you can see that, of 4.15 dBm.
Okay.
This allows us to check that the fibers are in good condition and that we're receiving the signal that we should be receiving,
okay,
from the back of the cards.
So 4.5 dBm is like a 3 milliwatt laser. Okay.
That's correct.
So in this technology, what we're doing is the technology inside these cards is a direct modulated laser. So we move that RF into optics. We're not digitally encoding it or anything like that. So it makes this technology very versatile. It's modulation agnostic, and basically what goes in should come out the other end, basically in very simplistic terms. On the receive side, we use special photodiodes. The trick about this kind of technology and the reason we're good at it and get the best dynamic range is we choose the best lasers. They typically come from Japan. We know how to get the best linear capabilities out of these lasers. So when you look at ViaLite and the products it presents, you'll see things like a lot around the high dynamic range of the product. So this has been 20 plus years of experience going into that. Okay, so we've got our basic system. So what about the SNMP card? What can we do with that?
So yeah, with our SNMP card, which is our HRC3 product that we see here,
yeah,
what it does, it gives us a representation of the chassis. So as you can see the chassis here,
yeah,
and we represent that on an internet browser. We can view the chassis with the IP address. And what I'll do, Richard, I'll just share my screen with you.
Okay.
And I'll just show you some of the areas down there.
Yeah.
And I'll just show you some of the features that we can use. So for example, we've got a link here. What I'll do, Richard, for you is I'll share that. I'll go into the receive card. So if I select the card, it'll bring up the options box on the right hand side. If I scroll down there, there's a control section. And in the control section, as you can see, it's currently software control enabled. Yeah. And we have a software target of 20 dBm.
So this is the gain setting?
That's the gain setting on the receive card. And we could do the same on the transmit card and any of the cards in there. So if I change that gain to 10 dB, and then you should see that change on the spectrum analyzer.
Oh yeah. Okay, so
we see the settings change, and you see the figure come back down again. Okay. So this gives us full control of all of our cards through the SNMP card.
Yeah.
And it's easy access because we can use any browser. I'm using Chrome in this example, to give us full access to the equipment itself.
Okay, that's great. And you can do other things like management reports and other types of.
This is quite useful, Richard. So yes, if we do have a customer in the field that's got some queries about the card, we can get an events report or a system report from the card, and we can get that sent across, which gives us a chance to investigate any issues that there might be.
Okay, great. So that's the basic system. It's a basic rack system, and the modules work very much the same way. You can also go in and do software gain adjustment of these modules as well, using tools that we can supply. So that's the basic RF over fiber system and the ViaLite approach. So one of the neat things though about RF over fiber and using optics is we can also use another benefit of optics, and that's multiplexing. So what that basically means is we can actually move multiple RF channels over a single optical fiber core. So there's various different levels. There's WDM, which is mixing or multiplexing two wavelengths onto a core. So we typically use 1310 and 1550 nanometer. Then we have CWDM, which allows us to do 16 light wavelengths, 16 channels onto a fiber core. And then we get up to DWDM. So technically you could go 90 plus channels. On systems that we've supplied worldwide, we've done typically maybe up to 30 or 40 channels. So it needs a few other products to enable that to happen. One of those key products is the multiplexer. So they're quite simple devices. I've got one gone here. So this is a ViaLite DWDM multiplexer. And on this particular example, it's got 8 channels, so they're mixed onto a common. So multiplexer, so this allows you to mux and demux those signals onto a fiber core. If you're going longer distances or you're coping with fiber losses that you need to compensate, you can also build in other products into the system like optical amplifiers. We call them EDFAs, and that allows you to boost the signal and bring it back up to the necessary level. There's other components as well. We can bring in delay lines. So in SATCOM, sometimes you want to time match signals, so you can bring in delay lines. So lots of clever tricks we can employ. And what that means is if you're moving lots of channels onto a single fiber core, then it becomes a very efficient way of moving lots of RF channels over much longer distances. So ViaLite's known, as I said, for about dynamic range. It's also known for the long distance links that it's installed globally, actually, in North America, Europe, and Asia Pacific. So in fact, Sean was recently working on a project, I think, in Indonesia.
That's correct, Richard.
Yeah. So do you want to talk through some of the challenges of working sort of in Indonesia?
So obviously at the moment with the current global pandemic, there's been some issues with travel, and unfortunately we were unable to travel to the location in Indonesia to do the installation and commissioning of the equipment. We've got partners in Indonesia, and using our partners were able to go on site and help us with the installation. Obviously, in this time period, we're seeing quite a lot of useful tools come out, which allow people to network across the world. And this is something we've done using one of Microsoft tools, TeamViewer. This allowed us to do complete remote support for the customer. And using our SNMP card, we were able to do all of the remote activities that we require, not only to the ViaLite equipment on the main racks, but also to all of the optical equipment, the optical splitters, the optical switch, and the EDFAs. So we were able to do all of that remotely, and by doing so, we were able to complete the installation and commissioning with our partners out there.
Okay.
And it was a very, very successful operation.
Okay, that's good. And I think, I mean, when we design these systems, we can kind of model the typical losses that we get on a link. So for a 1550 nanometer wavelength system, you know, if it was a perfect system, you might get like 0.2 dBs per kilometer of loss. Very, very low loss, of course, if you compare with coax. Where conditions are tougher, sometimes you get higher losses, maybe as high as 0.3 or even 0.4 dBs per kilometer. So in the ViaLite product range, we've got obviously products that compensate for that. I've talked about the optical amplifier. We also have high sensitivity receivers as well, which cope with a lower kind of optical budget and can cope with a more lossy path. The other thing in the ViaLite portfolio to help with long distance design is we've produced a cloud-based tool called the ViaLite System Designer. So this is something that our customers and we can use with customers to design the longer distance links and the more complex systems. So it actually uses models of all of our components and the long distance components like the muxes and the EDFAs, and it allows us to design these long distance links. So the installs that we've done have been over 100 kilometers. We've done designs upwards of 500 to 600 kilometers. So if you're interested in that, it's a great tool. It's a great way of learning actually about RF over fiber as well. You'll see more information about that on the resources section in the CommunicAsia stand. There's actually a presentation where I give a little workshop on using System Designer. If you want to get your hands on it yourself, contact us through ViaLite.com and request an evaluation license. You can give it a try yourself. Okay, so we've talked a bit about ViaLite systems. We've talked a little bit about long distance links. So just in this final section, wanted to talk about sort of an industry topic and how some other products relate to that. So LEO, low Earth orbit satellites and satellite constellations, obviously very present in the news right now with Starlink and the Amazon type projects. And OneWeb, of course, just recently been repurchased. So LEO is a very interesting business, very different to the GEO type satellites that we have today. So LEO is on a scale in terms of volume much higher than GEO. So we're talking about thousands of satellites basically orbiting the Earth. And from a ground segment perspective, it actually also corresponds to many gateways. In fact, some hundreds of gateways to support the LEO constellations have been planned. Now we're obviously working with customers on these LEO gateways from a ground perspective. They're interesting. So rather than GEO, you might just expect one large antenna. LEO is different. It's typically made up of a cluster of antennas. At least 5 antennas would be, I'd say, that what we've seen. Maybe as high as 20 antennas in a cluster in a particular gateway. Now, obviously, the industry is moving towards flat panel. We've still got many customers using moving parabolic antennas. So we've got a challenge here of many antennas. They can be sort of smaller scale. And what they need are products, particularly from ViaLite, which are smaller form factor and reduced weight. So I've talked a little bit about these modules, and these, of course, can be mounted on much smaller structures or moving structures. We also have a product called ODE-MINI. So Sean's just going to get it from underneath the desk here. So the ODE-MINI is a recent product from ViaLite. It's a fully IP-rated outdoor enclosure, so it's weather protected. And what we have inside it, it's kind of compact, kind of difficult to see here maybe on the camera, but what we have inside here, we can have up to 2 of these blue modules. We can also put our C-band link in here, which goes up to 7.5 gigahertz. So we have our basic modules. We have power supplies, so we can have 1 power supply, but like a chassis, we also have an option for 2 dual redundant power supplies, so for added reliability. We also have LNB powering. We also have, just in the right hand corner here, we have our mini site controller. So basically this is like much of the features of our SNMP cards, but built into this small form factor device. So this gives us full monitoring and control of the units, much in the same way as the rack system. So what we found, though, that this is actually a really important feature because, I mean, Sean deals with customers that are in the outside world.
Up ladders and towers, yeah.
Yeah, this stuff could be up towers and difficult to reach places. So what this allows us to do is we can connect to that via an RJ45 locally, but we can also bring that site information, that control information over optics as well, back to an internal rack. So this means you can actually monitor the system, you can configure it and control it actually from remote. You don't have to go up that ladder on a nasty wet day. So as it is like that in the UK often. It's got a lot of capability in a very small form factor. As I say, Leo, it's been very popular and very interesting for them. We also sold this for C-band and also for the GPS as well. So one of our most common products is to take a GPS signal and route it into a hard-to-reach area or data center or an underground location. So on the roof side or the top side, we can have a box like this connected to a GPS antenna. We move that into optics and then move that through into the internal control room or the data center areas. In fact, GPS is a whole another topic really. We've got a load of products on the ViaLite system, ViaLite website. We've got lossless optical splitters, we've got RF splitters, lots of neat tricks that we can do with the GPS side. So yeah, so Sean and I've been sort of talking. We've just been having a check on the chat just to see if there's I'm just going to have a quick check. So I think there's no questions in at the moment.
One thing I wanted to mention, Richard, if that's okay. So I didn't look at this before, but the cleaning of fibres, I can't stress how important it is, especially on installation and commissioning, that the fibres are clean. And it's a very simple process. What we do is we use a lint-free cleaner. So this is a cassette which is supplied specifically for fibre cleaning. And when you're on site, if you ever remove a fibre cable from a module or have to refit a fibre cable anywhere, please give it a clean first. These things are very susceptible to very fine particles of dust and dirt. So it's really important before you insert them that you clean them. And it's a very simple process. So with this cassette, if I push the button down, it releases the cloth, and I give it a little twist and a pull on each of the sections, and then that's now clean and ready to insert. So I can't stress, Richard, how important it is that when you are handling fibre cables, always give them a clean before you put them back into the receptacle.
What do we get in terms of dB loss if it's a dirty fibre?
It's really hard to tell, Richard. It all depends where the dust is, and these are such fine, small devices. There's a small piece of dust or hair that gets onto the end of the fibre. If it's in the wrong place, it can completely damage the signal, so you'll be looking at quite a significant loss, 3-4 dB perhaps. It all depends where that particle appears. So if you give it a clean first every time, lint-free cloth, make sure it's nice and clean, and pop it into the receptacle, and then of course it will be protected. Yeah,
okay, cool. Thank you very much. Okay, so I'm just having a look here. We've got a question on chat, so let me have a quick look at that. Yeah, so good question there about the benefits of RF fiber using an analog solution compared to RF and IP packets. So good question. So this, as I say, is a modulation agnostic product. What that does is it gives us access to tremendous bandwidths. So on our C-band link, it goes up to 7.5 gigs. It actually has a full 7 gigahertz wide bandwidth capability. Now, if you were to try to do that in an IP world and move that RF into IP, you would need much higher data rates. So you'd be looking at tens or hundreds of gigabit Ethernet to actually transform that equivalent bandwidth. So this technology is actually a very efficient way of moving very wide bandwidths onto fiber. It's also very low latency because we don't have to convert it into digital, so we've got no latency in the information that we're moving across. So great question.
And this is why we use single mode fiber as well, Richard.
Yeah, single mode. We should have mentioned that actually. This technology only uses single mode fiber. Multi-mode disperses the light too much for this kind of technology, so we only use single mode fibers. But to be honest, that is not really a significant problem because most people use single mode fiber now for most applications. So, so we've got another question. Can your SNMP connect to master NMS in an earth station? Yep. So we've got we've shown this through the web interface, but we also have a thing called MIBs. So this is the kind of the file format, if you like, for SNMP. So we have the MIB tables available and MIB control. And so if you're integrating that into an NMS system in a satellite earth station, they would be familiar with using the MIB tables and integrating that into the system. So you can just see the MIBs on there. Yeah.
Excellent. Thank you, Richard.
Great. Well, I think we're kind of coming to the end of the 25 minutes or so that we've got slotted for this. So just like to say thank you for joining today and your attention. We hope you enjoy the rest of CommunicAsia. It's been our pleasure to have a little chit chat with you, Sean and I. Yeah, if you want more information, come to the booth, the virtual booth at CommunicAsia. Reach out through the website. John Meyers is our local manager in the Asia Pacific region, so he'll be very happy to take conversations further with you. You can find him on the chat booth as well. So anyway, thank you very much for your attention, and good day.
Thank you.